Before we actually use transformations to graph polynomial functions, let me review with you what a polynomial function is. A polynomial function is a function of the form a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus all these terms down to a linear term a sub 1x plus a sub 0. So don't be too panicked about all of this. The a sub n's, a sub n minus 1, a sub 1, a sub 0, those are just constant terms. Or I shouldn't say constant terms, I'm sorry. A sub 0 is a constant term. The others are the coefficients of x to some power. So in this case, n has to be some natural number it's going to be 1, 2, 3, 4, and so on. Examples of polynomial functions, hopefully these you know. F of x equals 4x minus 2, that's a linear function, right? That's polynomial where a sub 1 is 4, a sub 0 is negative 2. F of x equals negative 2x squared plus 3x minus 1, that's a quadratic function. So there we have a sub 2, a sub 1, and a sub 0. Then we have a cubic function. And lastly is a fourth degree polynomial, or called a quartic function. So polynomial functions are really just terms added or subtracted where you have positive exponents in your variables. Some of the basic, we've already done this I think at some point, but just to review, y is equal to x is a basic polynomial function, the basic linear function. Y is equal to x cubed, y is equal to x to the fifth, then y is equal to x squared, x to the fourth, and x to the sixth. I've grouped them in this way for a reason. All of the odd degree polynomial functions have a very similar shape, as do the even degree polynomial functions. Okay? A basic even degree is an even function that is symmetric with respect to the y-axis. The odd functions are symmetric with respect to the origin. Okay? And another thing to note about that is when it's odd, it's doing opposite things across the y-axis, right? If it's down on one side of the y-axis, it's going to be up on the other side of the y-axis. When it's an even function, it's doing equal things on each side of the y-axis. So if it's up on the left, it's going to be up on the right. So keep that in mind. Now, the other thing I want you to look at is whenever we take the reflection of these, that is negative f of x, so there we're reflecting across the x-axis. And I really don't write this horribly. This is a graphing tablet, so it's sometimes difficult to write on these. So I'm reflecting across the x-axis. So notice what happens when I have negative x. This is negative x cubed, negative x to the fifth. The bottom is negative x squared, negative x to the fourth, and negative x to the sixth. So this time when we reflect across the x-axis, the behavior on the left and the right changes. It's still doing the thing that I said before. If it's an odd function, it's doing opposite things on each side of the y-axis. If it's even, it's doing equal things on each side of the y-axis. But the negative on that function changes the direction in which it starts from the left and to the right. Okay? Now, let's use those basic functions and do a transformation to get the sketch of this graph. Before we do that, one thing that I want you to note, for all the graphs of polynomial functions, they are smooth and continuous. There are no sharp turns or places of discontinuity. In other words, there's no holes or no gaps in a polynomial function. So if I wanted to graph y is equal to the opposite of x plus 3 to the fourth plus 4, I need to think about what is the basic parent function, what's happening through the transformations. So my parent function or basic function is y is equal to x to the fourth. And remember that was one that looked something like this, quadratic the parabola, something like that. So notice my chain of events here. I have a shifting in which direction. If I'm doing plus 3, I actually go to the left 3. The negative on the outside is going to be a reflection across the x, and then plus 4 is going to shift up 4. Okay, so I start from that key point of 0, 0, and let's follow that through. So if I go left 3 from 0, 0, it'll take me to negative 3, 0. So my graph is going up like that if that's the only thing I have to do, but now I'm reflecting it across the x, so now it's going to come down, and then I've got to shift that up by 4. Okay, so that vertex point is at negative 3, 4, and now it's going to shift down. Now I could precisely find out what those zeros are, and we'll talk about that in just a minute, but I just wanted to give you a basic shape of what that would look like. Okay. So the transformations, that really is nothing new to you. If you have any questions on how to apply these, please contact me, but really the other objectives of this particular section are going to be the ones that require more attention.